Hello and welcome back. Well, videos have been a little far and few between lately. I've been busy with a few other things on my plate, and one of those is an extension on a shed that I have out the back. So we've just started working on that, and we've put some piles into the ground with concrete, and we'll be starting to work on the floor shortly. Once this building is finished, I'll be able to move all my wood turning and woodworking gear and equipment into this building, and that will free up my larger garage for more engineering and fabrication work. On the table here I have a bunch of faceplates which are various sizes, and just like on an engineering lathe, a faceplate allows you to hold work in the lathe. These faceplates are for a wood lathe, and they're mostly used to screw onto bits of wood so that you can turn them on the lathe. A small one would be used for a smaller piece. Of course, you'd cut out the circle for your bowl. And if you have a bigger chunk of wood, then you'd use a larger faceplate. And again, you'd cut the circle out for your bowl. That keeps it all in balance. Now, faceplates are not always used to hold wood that you're working on in the lathe. For example, you might want to make a sanding disc, so you'd have a bit of round wood, and then you'd be able to put a faceplate on there. That will be screwed on through those holes, and then you'd have some sandpaper on this side, and that would screw onto the spindle, and then you'd have a sanding disc. In those situations, the faceplate is pretty much dedicated to the device that you're making. So the faceplate is then not available for use on making a bowl or for something else. Also, having a dedicated faceplate on a sanding disc is better than using a chuck, because chucks are very, very expensive. So a faceplate would be more preferable. Today I want to make a couple of these smaller faceplates. These are around about 80 millimeters in diameter. And I've got this piece of round bar here, and I'm going to make two faceplates out of this material. Now, with all these faceplates and with all my chucks, the thread here is 1 1/4 inch 8 TPI. So that's what I need to cut into the faceplate. Of course, I'll need to drill 4 holes in here as well. The first step is to mark out the length that I need. And to get this square all the way around, I use a bit of plastic. And if I set that up square, then this line will be perfectly around the piece of steel. Then I cut that out with the angle grinder. Unfortunately, the disc is not big enough to get through the middle, so I have to revert to a hacksaw. I cut those 2 pieces off, and then it's over to the lathe to tidy them up. Now I've got a little bit sidetracked here. I need to make up a mandrel or an arbor so that I can screw the faceplate onto it. So I've got a bit of 50mm bar here, and I'm turning down the end so that I can put a thread on it. This is not part of the faceplate build, so I'll quickly go through it. In fact, it will be a part for a future video, so I'll put all the details in that future video. Here I'm cutting a 1 1/4 by 8 TPI thread, and that will fit my faceplates. I test a chuck on there because that's got the same thread, and that works out perfect. Then I work on the other end, and this needs to be turned down to 20 millimeters. I start turning that down on the left, and then I take that piece out that's on the right, and a finish cut all the way down. And I tidy that up with a bit of sandpaper. As I said, it's just a mandrel so I can hold the faceplate later, and that will allow me to cut some flats on it. And that's how it fits together like that. Okay, we're back on to the actual faceplate. So I've got it in the lathe here, and I need to take out a lot of material here. So I've done most of that off camera. I'm just doing some finishing passes now. I checked the measurement there, and that looks good. I've flipped the part around in the lathe, and I'm holding it on the surface that I just machined. So now I'm just truing up the outside surface here. I now start working on the thread. I need to drill and bore out the center here to around 28.5 millimeters. That's the size we need for 1¼ diameter thread. Off camera, I ground a tool at 60 degrees and it's in a homemade boring bar. I start off with a scratch pass, and that is checked with the thread pitch gauge. It's pretty much rinse and repeat. I did most of this off camera. You're basically cutting in and then back the tool off and then wind the lathe back out. I always keep the half nuts engaged when doing this process. That comes from using my other lathe, which does not have a thread dial, so I've got quite used to it now. When you get close, you just do little cuts until the part that you want threads in there, and that works out beautifully. I tidy the edges up with a chamfering tool and also flip the part around, and I turn a little recess off camera and then chamfer this corner as well. So pretty much all the lathe work's done. I've got to drill some holes in here, of course, but first I'm just going to check it out on the spindle. And that looks good. Now I have that other part in a square collet and I can screw this faceplate onto it. I make sure it's nice and tight because we're going to drill the holes next. I found the center here by using a drill bit, and now I can use offsets in X and Y the same amount to drill all of the holes. These are 6mm holes to be able to take tech screws, which are a little bit bigger than normal screws, but they have a hex head so they can be screwed in quite easily. I had it all set up in the collet block, but I realized that I was going to cut into this collar here when I cut the flats on this piece if it was still screwed in here. So I've taken it out and we'll just cut the flats in the vise here like this. I've measured the width of the spanner, so I'm taking the even amount off each side, and when I do the other side I sit this machine part on a parallel, and then I know I'm parallel with my next cut. The machining is pretty much done. It looks good. Let's try it out. I have the spindle locked. Spanner slides on quite nicely and we can just nip it up like that. Now some of you may be wondering why I'm putting countersinks on this side. This is the side that goes onto the wood. And the reason is because sometimes the wood can puff up and push the faceplate away when you bolt it down. So these countersinks give a little room for that wood that wants to get pushed in there. These are the two faceplates that I made out of this round bar here. And I plan to cold blue them to protect them from rusting, so I'll do that a little bit later. The new spanner I made fits onto these perfect, so I'm happy with that. Now you may be wondering why I made these faceplates when I have all of these faceplates here. Well, a lot of these are from other people, so they're not mine, and I did want to make a couple of smaller faceplates. As mentioned in the introduction, one of these will be used for a sanding disc, so I'll make that up at a later date. Now you may recall that this piece was not part of the project, but I did make it to assist with drilling the holes in the faceplates. So it is part of a future project, and these are the plans. That piece there is the one that I've made, and there's all these other pieces that need to be made as well. If you want to have a guess what this project is, then leave it down in the comments there. Otherwise, this will be in a future video. I hope everyone has a great day, and once again, thanks for watching.